Welcome to our channel for probability and statistics. In this video, we will talk about the log-normal distribution. So log-normal distribution is a continuous random variable. X has a log-normal distribution if the random variable y equals log x has a normal distribution with mean mu and standard deviation sigma. So log-normal distribution has density function quite similar as normal distribution. The only difference is this part has an x here, right? Difference, and here we use the log x instead of the x in normal distribution. And the log-normal distributions available variable is only for positive number. And the mean of the log-normal distribution is mu plus sigma square divided by 2 in power. And the variance is e 2 mu plus sigma square then times e sigma square in power minus 1. So in this figure, there's two log-normal distributions density curve are shown. This for the mu equals 0 and sigma 1, and next one is mu 1 sigma 1. We take a look at two examples. The first example is the concentrations of pollutants produced by chemical plants historically are known to exhibit behavior that resembles a log-normal distribution. Suppose it is assumed that the concentration of a certain pollutant in parts per million has a log-normal distribution with parameters mu 3.2 and sigma 1. So the question is, what is the probability that the concentration exceeds 8 parts per million? So the solution is let random variable x be pollutant concentration. So we want to know probability of x larger than 8, which equals 1 minus the probability of x less than equal to 8. So since log x has a normal distribution with mean mu 3.2 and standard deviation sigma 1, so we can use the cumulative normal distribution. Probability x less than 8 equals cumulative probability of log x minus mu divided by 1, right? Because log x has a normal distribution. So we can use log x minus mu divided by sigma will have a z value which is a standard normal distribution random variable. So we can get directly for this part from the normal distribution table, which equals 0.1314. And the second example is the life in thousands of miles of a certain type of electronic control for locomotives has an approximately log-normal distribution with mu 5.149 and sigma 0.737. So the question is, find the 5th percentile of the life of such an electronic control. So the solution is, from normal probability table, we know that the probability of z less than minus 1.645 is 0.05. So we find the z value first for the normal distribution, which get the cumulative probability 0.05. So this z value is minus 1.645. So if we denote x by the life of such an electronic control, since log x has a normal distribution with mean mu 5.149 and sigma 0.737. So the 5th percentile of x can be calculated first as log x. Because log x is a normal distribution, we find the z value, this value, so we can get log x equals this z value plus this z value times sigma, then plus mu, which equals 3.937. So because log x equals 3.937, so we take power of e of this term, we will get x equals 51.265. So this means that only 5% of the controls will have lifetimes less than 51.265 miles. Thanks for watching.